Good morning, everyone. Today we will see branch and bound technique for solving traveling salesman problem. First, we will see what is branch and bound technique. This is mainly useful for solving optimization problem. The solutions can be uh, maximum value or minimum value. Uh, Optimal solution can be divided into two types. That is maximization problem or minimization problem. Branch and bound technique used for solving both maximization problem and minimization problem in efficient way. So, what is optimal concept for branch and bound technique? Here, the problem is divided into sub-problems that can be expanded to the next level. So each and every level, we have the solution for sub-problem. So choose the sub-problem with optimal value. That is the called local optimal solution. That can be expanded to the next level to find the global optimal solution. And it can be represented. Branch and bound approach can be represented in the form of tree structure. Tree has root node. Root node has initial value and that can be explored in all possibilities. That means that it solves the problem of sub-problem of for the first stage. The problem is divided into sub-problems. All sub-problems are solved at the final first stage, first level. So after finding the solution of sub-problem, compare the result. So which problem has maximum value or minimum value for minimization problem. So the minimum value sub-problem can be considered as a local optimal solution that can be expanded to the next level. So there are four processes in branch and bound technique. First one, exploration, branching, bounding. Here's a lower bound function and pruning. So what is exploration? We will see one by one. What is exploration? We are finding all sub-problem solutions. That best sub-problem can be selected. That can be expanded to the next level till complete solution is reached. So exploring the same step again and again till we are getting the complete solution to the given problem. That is called exploration. What is branching? Finding all possibilities, all sub-problems at one particular level. Each and every level is called branching. Number of branches. Number of possible sub-problems is called branching. And what is bounding? So we are finding the value of subproblem. So we have to choose the best subproblem at a particular level. That is called bounding function. We are choosing only one best solution at local. So remaining subproblems are eliminated, not considered for exploration. That is called pruning. So choosing the best one is called bounding. Eliminating remaining non-promising solutions is called pruning. And we will see what is traveling salesman problem. So there are n number of cities in a region. So the salesman has to visit all the cities exactly once. He has to start at one city, then he should visit all the remaining cities exactly once, and from the last city, he should reach the first city. That is called traveling salesman. Where he started, he should reach the starting place. That is called traveling salesman problem. Here, this is example for minimization problem. The traveling cost should be minimum. There are number of paths available. We have to choose the path with the minimum cost. That is called traveling salesman problem. The cost can be traveling cost, or it can be time, or it can be distance. So the minimum path, shortest path can be taken as an optimal solution. So we are applying branch and bound technique to solve traveling salesman problem. So this is a minimization problem. We are taking lower bound value LB. So how we can find out LB value? that is seal of sum by 2. Seal of sum by 2. So for each city I equal to 1 to n, find the sum Si of distance from the city I to the nearest cities. Okay. So we are taking each and every city. We are finding the distance from city I to the nearest cities and compute the lower bound value, that is LB divided by 2. That is LB is total distance divided by 2. Calculating the sum of SI for all the cities and divide the results by 2. So that is the lower bound function for minimum cost. And the problem statement is to find the shortest path that visits all cities exactly once and returns to the starting city. That is the problem statement. Given number of cities, n number of cities are given and distance between each cities are given. The cost to travel from one city to another city is given. And what we have to find out? To find the shortest optimal tour. Optimal tour means the path with minimum cost that includes all cities exactly once and returning to the city with minimum cost. That is the result. What's the constraint? He has to visit all the cities exactly once and he should reach the starting city. So the traveling cost should be minimum. So that is called constraint. Constraint is all cities should be visited exactly once and return to the starting city. And what's the objective function? This is traveling cost should be minimum. Minimum traveling cost. So that is a lower bound function. So we are using lower bound minimum value. So the formula is LB equal to sum divided by 2. So what is sum? Sum of distance from current city to the nearest city is calculated. That is called total sum. Divide the result by 2. We are getting the lower bound value for each node. And we will see one example. Apply the branch and bound algorithm to solve traveling salesman problem for the given graph. So see the diagram. There are 5 cities A, B, C, D, E, and distance or cost from one city to another city is given. That is called edge cost. Each city is labeled with alphabets. A is a city, B, C, D, E is a city. And what is the cost? To travel from A to B, the cost is 3. So that is the given data. Step 1, find the cost matrix C. So there are 5 cities. We have to form 5 cross 5 matrix. 5 rows and 5 columns. There are 5 cities, n equal to 5. So we have to form n cross n matrix, that is 5 cross 5 matrix. So give the label for each row A, B, C, D, E. All 5 nodes. The column also A to E, 5 nodes. All diagonal values are 0. The reason is A to A, B to B, C to C. The distance from A to the same node A is 0. The distance to the same node is 0. All diagonal values are 0. Then this is an undirected graph. So A to B is 3 and also B to A is 3. So we can take both way. So for example, for node A to A is 0. Self node always distance 0. A to B is 3. So fill the value A to B 3. Then A to C is 1. Fill A to C 1. Then A to D is 5. And A to E is 8. So like that we have to fill the cost matrix. This is the first step. And the second step is construct a state space tree. Find the root node value using the formula LB is equal to sum by 2. So how to find LB value? This is root node A. So see the formula. Node 0, LB equal to sum by 2. That is seal value. Sealing means we are taking the lowest integer. For example, 35.7. So we have to take 35. So we are taking the floor function here. So floor means LB is, for example, take the city A, node 0. LB is equal to, for node A, what is the value? So we have to take minimum the first row, take minimum first two values. So leave 0, 1 and 3 is minimum. So 1 plus 3. So take 1 plus 3. For node B, for the node B, uh, for the node B from this matrix, take first two minimum. So 3 and 6. Like that, we have to take the value, two nearest city for each node for A, B, C, D, E. Add the values and divide by 2. That is 14. 14 is the lower bound value for the root node. And next level. So there are four possibilities. From the city A, the person can go to city B. It's the first option. That's called branching. He can go to either C, A to C, and A to D, A to E. There are four possibilities. So here they are giving on constraint. B is not before C. After visiting B, only C can be visited. So the node 2 is pruned that due to the constraint. And C, find out the node 1 value. So A to B is fixed. So for each node, we have to find first two minimum value. So for node 1, see for node 1, lower bound value is first two minimum. So in that, we have to fix the city AB. One more value is take minimum value from the remaining values. So lower bound value is 14, and for node 3 lower bound value is 16, and node 4 lower bound is 19. So which node has minimum value? This is a minimization problem, lower bound value. So node 1 has minimum LB value. So 14 is less than 16 and 19. So node 3 and 4 is not optimal. Node 1 is optimal. So that is called bounding. So we are removing node 2, 3, 4 are removed from the solution space. So node 1 is selected for exploring to the next level because it is optimal at first level. It has minimum value LB. So next, expand to the next level. Node 1 is expanded. So we are finding path. So A to B is visited. From B, there are three options. The traveling person can go to C. So it's the first option, A to B, B to C. Or from A to B, B to D he can go. From B to D is another option. And node 7 is from B he can go to E city. So there are three possibilities at this level. From A to B is fixed. So from B he can go to city C or D or E. So there are three possibilities. So find out the LB value. So for node A, AB cost is fixed. And the remaining one we can take from the cost matrix and find out LB value. Find the sum divided by 2, that is LB value. So 5, 6, 7. See the value. Node 5 and 6 has same value 16, 16. And node 7 is LB value is 19. So this value is maximum. So we can eliminate pruned. So we are choosing 5 and 6 because it has same value tie occur. So both can be export to the next level. See, now node 5, A to B, B to C is visitor. Next remaining is C to D. So C to D means last 4 nodes are visited. Last one left out is E only. So we can add D to E is the first option. Then E to, after reaching the last node E, he has to visit starting city A. So fix a complete cycle. A to B, B to C, C to D, and D to E, E to A. Find the lower bound value. And node 9, so another option. A to B, B to C. From C, he can go to D or E. D means node 8. Now, from C, he can go to node E also. That is another option. From E, 4 nodes are visited. Only one node left out. That is D. So, we can add E to D. So, all nodes are visited once. Then, he can return to the starting city. So, from D, he can add A. So, we have complete path. Find out lower bound value. Like that, from 6, there are two possibilities. A to B, B to D. From D, he can go to C or E. That is option node 10 and node 11. After visiting the node, only left out for 10 is E. For 11 is left out is C. So all nodes are visited. Finally, add the starting node. So find out the lower bound value. See 8, 9, 10, 11. Lower bound value 24, 19, 24, 16. So node 11 has the minimum lower bound value 16. That is optimal. This path gives minimum cost. This is the shortest path. A to B, B to D, T to E, E to C, C to A. The total cost is, the optimal shortest cost is 16. So this is a final result of traveling salesman problem using branch and bound technique. So for each node, how we are finding lower bound value means for each node take minimum 2 value and two nearest cities and add the value divided by 2, that is the final answer. And what's the time complexity of branch and bound using solving for traveling salesman problem in worst cases order of n factorial. This is like a brute force. We are checking all the possibilities where n is number of cities because the algorithm may have to explore all possible permutations of cities. So branch and bound uses lower bound estimations to eliminate paths that cannot be lead to a optimal solution. So the time complexity of traveling salesman problem using branch and bound in worst case is order of n factorial because it in worst case it checks n possibilities. So the time complexity n in, for n cities n minus 1 is n minus 1 into n minus 2 like that. So we are getting n factorial. Branch and bound is better than brute force due to pruning. So in normal best case and average case, some nodes are pruned, some parts are pruned. So which is it is more efficient than brute force approach because of pruning approach. Thank you.